Good morning, everyone. In this video, I'm going to discuss the latest homework of paragraph 7.1. I'm going to go over all the exercises and hopefully get them. First one, exercise 2. You had to write down all the divisors of 18. So if you have to do that, the easiest way to do that is start with 1 times 18, which means that 1 and 18 are both divisors of 18. Then the next one, 2 times 8, 2 times 9 is also 18. So 2 and 9 are also divisors. So you're trying to find products of 18 with different numbers. And I'm trying to make the first number bigger and bigger. The next one, 3 times 6. So 3 and 6 are also divisors. If you're thinking about 4, well, if you divide 18 by 4, you don't get a whole number. Same goes for 5. So these, and then I'm at 6 again, these are all the divisors of 18. The next one, 60. 1 times 60. 2 times 30. 3 times 20. 4 times 15. 5 times 12. And 6 times 10. So 60 has a whole lot of divisors. Am I forgetting one? 7 is not a divisor, 8 is not a divisor, and 9 is not a divisor. So these are all of the possible divisors. The last one, 78. 1 times 78. 2 times 39. Can we divide this by 3? Yes, because 7 plus 8 is 15. So 3 times, let's see, 26. Can we divide it with 4? No. 5? No. 6, we can divide it with 6. So 6 times 13. Can we divide this with 7? No. 8? No. 9? No. 10, no, 11 and 12 as well. So these are all the divisors of 78. Let's go to question 3. Check whether these numbers are divisible by 3, 4, 5, 6 or 9. So the first one, 118. We can divide it with 3 because 1 plus 8 is 9 and we can divide that with 3. These last two digits are divisible by 4, so we can divide it by 4. The last number is a 0, so we can divide it by 5 as well. We can divide it with 2, we can divide it with 3, so we can also divide it with 6. And if we add these numbers together, it's 9, so we can also divide it with 9. Next one. 648. If we add these things together, we'll find 18, which means we can divide this with 3. The last two digits, 48, we can divide that with 4. The last number is an 8, so we can't divide it with 5. We can divide this with 3, we already know that. Since the last number is a 2, we can also, the last number is an 8. That means we can also divide it with 2. So since it is divisible by both 3 and 2, we can also divide it with 6. Going to add them again. It's 18. We can divide that with 9. So this is also divisible by 9. The last one, 2025. If we add all these numbers up together, it's 2 plus 0 plus 2 plus 5. That's 9. Which is divisible by 3. The last two digits, 25, we can't divide that with 4, so we can't divide it with 4 at all. The last digit itself is a 5, which means we can divide it with 5. Since we can't divide this with 2, we also are not allowed to divide it with 6, so I'm going to exclude that one. This one, 9. All of these digits added up together gives you 9, and we can divide it with 9. So let's go to the next question. here. Question 6. Which of these statements are true? The sum of the divisors of 48 is divisible by 3. Which means we first need to find the divisors. So all of the divisors are 1 times 48, 2 times 24, 3 times 16, 4 times 12, nothing with 5, 6 times 8. These are all divisors. So if we add all of these things up, this is 49, 51, 75, 78, 94, 98, 110, 116, 124. So adding up all of these things together gives us 124. If we add these digits up together, it's 7, so it's not true, it's false. The next one, every natural number that is divisible by 3 is also by 3 and 5 is also divisible by 15. Well, think about it. If both of these factors are in there, you can always divide it with 15 as well. So this one is true. C. Every natural number that is divisible by 2 and 4 is also divisible by 8. Think about that. Well, there's actually a really easy counterexample. If you look at the number 4, four is divisible by 2, 4 is also divisible by 4, but this is not divisible by 8. Next one. D. There is no natural number that has 0 as a divisor. Well, if there would be such a number, then 0 times some number is a number. That's never true, because this is only true if y equals 0. If that final number is 0, but that's not a natural number. So there is no natural number that has 0 as a divisor. This statement was true. E. Every multiple of 6 is also a multiple of 3. Well, since 3 is a factor of 6, that is true. Think about it. 6, 12, 18, 24, 30, all of those are also multiples of 3. So this was true. The last one, F. Every natural number is a divisor of 0. Well, think about it. Let's pick a random one, for example 17. Can we multiply 7 with some number and with 0? We can divide, if we can say that x is 0, so you will probably say it's true, because you can find all of these products. Okay, let's go to question 8. Find out which of these are prime numbers. Well, 32 is 2 times 16, so this is definitely not a prime number. 59. Well, usually when you want to check for prime numbers, you have to look at the first 10 numbers or so. You can't divide this with 2, not with 3, 4, not 5, not 6, not 7, not 8, not 9. Well, as it turns out, this is actually a prime number. The next one, 97. Let's see, we can't divide this with 3 because the sum is 16. So you can't divide it with 5, not with 7, not with 9 because the sum is still 7, not with 11, not with 13. So this is also a prime number. 134. 43. Can't divide it with 2, with 3, because the sum is 8. We can't divide this with 5, not with 7. This is a tricky one, because this is 11 times the 13. So maybe some of you actually wrote down this is a prime number, because this is pretty hard to find. These really big prime, this idea of using prime numbers to find bigger numbers is also used in encryption, because it's really difficult to find these two factors. The next one, 159. Let's think about it. The sum is 15, so we can divide this with 3, and then we're already done. So this is not a prime number. 1001. Difficult one. We can't divide this with 3. Cannot divide it with 5. We can check for 700, but let's see. I think we can divide this with 700, because that's 7 times 143. I think this is actually correct. This is not a prime number. So even though there are not really easy rules for 7, always check 7. Let's just make sure that it's 700, 280, 21, yeah. The last one, 9. Why is 18 not a prime number? Because 18 is 2 times 9. That's an argument. Write down the only even prime number. Well, 2. It's the only even one. See, write down all the prime numbers less than 30. Okay. 2, 3, 5, 7, 11, 13, 17, 19, 23, 24, 25, 26, 29. So these are all prime numbers. Write down the first prime number that is bigger than 50. 51 is divisible by 17, 52, 53. Let's check that one. We can't divide this with 7, not with 9. I think this is the first prime number that you'll find. How many prime numbers are there between 190 and 200? So these are all the numbers that are in between there. And we're going to try and remove them as we're working on it. So all of the even numbers are divisible by 2. So we can remove them. Then I'm going to think about this one. The last digit is a 5, so we can divide it with 5. Then there are 4 numbers left. Can we divide any of these with 3? Let's see, this sum of these is 11, the sum of these is 13, the sum of these is 17 and 19. Can we divide these numbers then with 7? Let's see, which 100... This number is divisible by 7, which means that 189 is. So all these numbers are not divisible by 7. Let's check 11 really quick. This one is divisible by 11, so that means something over there as well. Let's finish off with checking for 13. This one is actually divisible by 13. The others aren't. Are we going to check for 17? Don't need to. So these are all the prime numbers. So there are 1, 2, 3, 4, If you have any more questions, just let me know.